Okay, so we will continue on in chapter 7, okay? And I'm going to skip section 7.5, okay? So this 7.5 doesn't even exist in the first edition, okay? So it's not in the first edition of the textbook. And I know there was like the confusion at the beginning of the quarter about what to do with the textbooks. So we're going to skip section 7.5. It's okay. I don't feel like you're going to miss out too much. I mean, we're skipping a section in the textbook, but I think we'll be okay. But there's still a lot to talk about regarding confidence intervals. So we'll start off with a clicker question, kind of going over the calculation of a confidence interval. And then the rest of today's lecture will just focus on all of the types of conclusions that we can make from a confidence interval, what a confidence interval means, which in my opinion is just as important, if not more important. Okay, so let's see. All right. Let's say you are interested, and I just completely made up these numbers. So you are interested in the proportion of people who own vehicles, or who own a vehicle. And all right, and so we'll say you survey 550 randomly selected people, and we'll just pretend like it was not too much difficulty to get 550 randomly selected people. Okay, and you find that 350 of them own a vehicle. Okay, so I'm going to say make a 90% confidence interval for the proportion of vehicle owners in the population. Okay, these are going to be your answer choices. Let me get the clicker going here. Wait. 621. 2.651. Okay, 90% confidence interval. Go ahead and try this out. if you're watching on YouTube, I'm gonna pause the video here, and then when I unpause, we'll go over the answer. So I'm pausing. I recommend you do the same. Okay, I'm gonna click stop here in just a second. So here I go. Okay, and that is the correct answer. Okay. Okay, so to solve this, we would have to figure out our sample proportion, okay? So as we go through, it says we've selected 550 random people. So n, our sample size is 550, and 350 of them own a vehicle. So the number of successes we have is 350. Our p hat is 350 divided by 550. And we get 0.63636, or I'll just round off to 0.6364. Okay. The confidence interval is p hat plus or minus z star times the square root of p hat times 1 minus p hat over n. Okay. And so our standard error is going to be 0.6363 whatever times 1 minus that same number. So I'm just going to do answer times 1 minus answer. Whoops. I messed that up. 350 divided by 550. So we're going to have answer times 1 minus the answer divided by 550 divided by n. Okay. I'm going to take the square root, and this will be my standard error. So I have p hat plus or minus z star times 0.0205. I hope that's okay with everyone. All right, and then so for a 90% confidence interval, if we want the middle 90%, then our cutoffs are at z equal to negative 1.645 and z at positive 1.645. Okay, so this gives me, and so I guess with all of our numbers plugged in, I've got 0.6364 plus or minus 1.645 times 0.0205. Okay, and so when I do that, I get 0.6364 plus or minus this times 1.645, 0.0337. Okay, and if I do the plus or minus, I get this. Okay, maybe ever so slightly different just because of rounding, but essentially this is what I get. Is that okay? Calculation of a confidence interval? Question. Where does the 1.645 come from? I believe I gave you a list of kind of 4 z-scores that you should know, and I also said if you don't, like, you can always figure out, like, if you want 90% in the middle, then whoops, you would want 5% in each tail. So the z that corresponds to giving me 5% in the lower tail is basically 1.64 or 1.65, and that's where we're getting. But I also gave you, I said there are 4 values that you should know. For 99, it's 2.58. For 95, 1.96. 90 is 1.645, and then 80 is 1.28. And I'd say between those 4 values, that covers almost every confidence interval you would need to make. On rare occasion, you might make some 92% confidence interval or something, but rarely. Okay. Good? All right. So let's talk about the conclusions we can make. So we would say from this, we would say I am 90% confident 90% confident that the proportion of vehicle owners in the population is between 0.602 and 0.670, okay? So we are 90% confident that the proportion of people who own vehicles is between 0.602 and 0.670, and that's the proportion in the population. It's always about the population proportion. Okay? So far, so good? All right, so let's, I did this last class, and, well, we'll see how you guys do, and then maybe I have to do what I had to do over there also. Okay. So, so based on this, so basically our 90% confidence interval goes from 0.602 to 0.670, okay? And the appropriate conclusion is I am 90% confident that the proportion of vehicle owners in the population is between 0.602 and 0.670. Okay, so I'm gonna ask a question. Do we have evidence that the proportion of vehicle owners in the population is not 0.670? Okay, and this will be a clicker question. Okay, and you can discuss with your neighbor. Yes or no. Okay, what do we think? All right, so, okay. I will, I'll give you the answer, and then you can change your answer here, and then, and just make sure you get it right. Because I did this for the other class, so it's only fair if I do the same for you guys. But the answer to the answer is yes, okay? Oh, yeah, okay. All right. So change your answer so you have a yes, okay? All right, so let's just talk about this, okay? 4 people haven't clicked yes yet. Okay, well, anyway, Two people. All right. One person, you're still, you got it wrong. Okay. So do we have evidence that the proportion of vehicle owners in the population is not 0.670? Okay, so we look at 0.670 and we say 0.670 is, oh my gosh, I'm such a dummy. Yeah, well, okay, so 0.670 is, I hate myself. This was supposed to say 0.675. I'm a dummy. Okay, all right. So that changes everything, right? Okay, that changes everything. Okay, so I apologize. Okay, well, I'm glad I'm giving everybody the answer here. Okay, all right. So, do we have evidence that the proportion of okay? So we look at this and we say, well, 0.675 is not inside our interval. It's not between 0.602 and 0.670. I'm so sorry. This is like you guys were debating, like it's on the edge and things like that. Okay, so 0.675 is not between 0.602 and 0.670, okay? And so we would just say 0.675 is outside of the range. And so therefore we have evidence that it is not is not 0.675. Okay, so the answer is still yes. The answer is still yes. So somebody changed their answer back to no, but I got it. Make sure you everybody just click A on their. Okay, everybody got it right now. Okay, so there we go. All right, everybody, good. Everybody got it right. Okay. However, if I had written this and say does our confidence interval prove that the population proportion is not 0.675? The answer here is no. Okay, and the key difference here is that it's saying, does it prove that the population proportion is not 0.675? No, our confidence interval doesn't prove anything, okay? Confidence intervals don't prove anything. Okay, yeah, I apologize for having a different number there, okay. So confidence intervals don't prove anything, and this statement here, when we say we have evidence, there is, we're only 90% confident in our answer. Okay, so when we say yes here, we are 90% confident. Okay, is this okay? All right, let me just copy everything here, and we're going to basically have all of this stuff, okay? If I use the exact same data, let me actually just, okay, with the same data, if I make a 95% confidence interval, goes from, and we can calculate this, it would be, p hat plus or minus 1.96 now, times the standard error, okay? That would go from 0.595 to 0.677, okay? All right, so our 90% confidence interval, I'm sorry, our 95% confidence interval goes from 0.595 to 0.677. All right, let's say I ask the same question here. Do we have evidence that the proportion of vehicle owners in the population is not 0.675? Okay? The answer now is no. Okay? And we would say 0.675 is inside our interval. Okay, 0.675 is inside our interval. Therefore, we do not have evidence, or we would say 0.675 is a plausible value of the population proportion P. Okay, and so we do not have evidence that it is not .675. Okay, is this okay? All right, and so, but we're looking at the same data, okay, and we asked the same question. So how can we get two different answers, right? So earlier, exact same data, I created a 90% confidence interval, and I said, do we have evidence that the proportion of vehicle owners is not 0.675? And we said, oh, 0.675, it's outside of our interval, so it's not a plausible value. Yes, we have evidence that it is not 0.675. Same data, same question, and this time 0.675 is inside our interval, and now we're saying we don't have evidence that it's not 0.675. How does this work out? Well, what changed between the previous slide and this slide? The level of confidence. The level of confidence. So when we want to be more confident, our interval got wider, and we had to change our answer from yes to no. Okay. And so you can kind of take this as like if you, I don't know, if you're ever like the boss of something and you have to make decisions and call shots. Okay. A lot of times you have to make decisions based, and you don't have all of the information. Okay. And you can choose to make a decision with limited information, and I guess you can. There are a few approaches, right? You can be more cautious in your decision making, or you can be a little bit more risky. Okay, and these probably just reflect two different personality types and things like that. And neither one is right or wrong. Okay, it's just it's different. So if you wanted to be extra confident about before you say yes that we have evidence against something, in this case, if we want to be 95% confident, we would have to say, no, I'm not ready to reject this number 0.675. Okay? If we're willing to be less confident in our answer, we can say, I am ready to reject this number of 0.675. Okay? So there's a trade-off between your confidence level and what values you will accept or reject. Okay? And so you can create a more narrow interval, but the trade-off is you're going to have less confidence about your answer. Okay, and so here, this note, there's 95% confidence going here. So it's a lower confidence, meaning you might be wrong more often, can create more narrow intervals. Okay, and that's basically the difference there. Okay, so lower confidence leads to narrower intervals. Okay, so and this is the trade-off. Narrower intervals is generally a desirable thing, but lower confidence is the less desirable thing. Okay, so what's the right thing to do? I don't know. Okay, we never know. We never know. That's life. You make a choice and then deal with the consequences. Okay. But okay, let's continue on. So we got, our 90% confidence interval is basically 0.602 to 0.670. Okay, and then our 95% confidence interval is what? 0.595 to 0.677. Okay, so all right, if we, so here's a question. Can we say we have evidence that the population proportion of vehicle owners is 0.640, okay? So decide, true or false? Okay, it's a clicker question. So 0.640, that's inside our interval. And the question is, can we say, we have evidence that the population proportion of vehicle owners is 0.640? Okay, so go ahead and discuss with your neighbor whether you can or cannot say this. So I'll pause the screen. Okay, I'm going to hit stop here. All right, let's see what you guys think. Okay, so we're divided, and the answer is B. Okay. Okay, well, all right, so I'll explain this, okay? So what we said is, 0.640 is inside the interval. That much is true. Okay. What if I had written the same statement and what if I had written this sentence? We have evidence that the population proportion of vehicle owners is 0.650. Well, those of you who said true here, you'd have to also say true here, right? Based on, well, I don't know. Is this true? Okay. Well, I mean, if you said true up here, then there's no reason to say something different down here, okay? Because 0.650 is also in the interval. But how can this be the case, right? How can we say, well, the population proportion is 0.640, and at the same time the population proportion is 0.650, okay? It doesn't work out, okay? You cannot have this, okay? So 0.640 is inside the interval, okay? We can say 0.650 is in the interval. Okay, but they both can't be true, okay? But P cannot be both 0.640 and 0.650 at the same time, okay? That's just not possible, okay? So all we can say is that 0.640 and 0.650 and any other value inside the interval are plausible values. Plausible values of P. Okay? But that does not mean we have evidence that it is said value, okay? That P is, 0.640 or 0.650, okay? All we are saying is that these are plausible values. Okay? Is that okay? So let me flip next slide here. Okay, so you can imagine some number line, okay? So some proportion between, so the population proportion is somewhere between 0 and 1, okay? We observe a sample, and where you observe the sample, that is p hat, okay? So your observed sample proportion is p hat. Okay, and then you create a confidence interval. You go up, this is called the margin of error. And you go down the same amount. Okay, so your margin of error is what? Z star times the square root of p hat times 1 minus p hat over n, okay? And so this just produces, inside your confidence interval, these are plausible values of population proportion p. Okay. And that means everything outside of that these would be implausible values, okay? Okay. Implausible is not impossible, okay? It is still possible for P to be in this red region, okay? It's just unlikely, it would just be surprising to us, okay? So P could be. So we would say things like, we have evidence that P is not in the implausible range. Okay, but it is still possible for P to be there, okay? Okay, so technically all of these values are possible values, but some of them are plausible and some are implausible, okay? Okay, is that all right? I'm afraid I'm going to run out of time here, but so I want to talk about what exactly does it mean for us to have 95% confidence, okay? %95 confidence, what does it mean? Okay, so imagine we've got the big tub of candy again. Okay, we don't know the proportion of blue M&Ms, so we take little scoops out. Okay, so let's say every student gets a random sample of candy, all right? And then so each of you, you come up to this imaginary tub and you scoop out your M&Ms, okay? And then every student creates his or her own confidence interval. So every student creates we'll say 95% confidence interval based on their data. Okay. We then reveal the true proportion of blue M&Ms, okay? The true value of P, the proportion, population proportion. Okay. And then we say, did your confidence interval capture the true value of P? Okay. Well, we would expect about 95% of the students' confidence intervals to have captured the true value of P. Okay? So about 95% of the students should say yes. Okay? But before we reveal the true value of P, and we can only do that in this fictional setup because in real life we can never actually look at the population, okay? But prior to figuring out P, okay, you don't know if you actually have, you don't know if your proportion is correct. I'm sorry, you don't know if your confidence interval captures is correct. So you do not know if your confidence interval is quote unquote correct, if it manages to if it successfully captured P. Okay. Oh, there's like one more sentence I want to write. All right, so let me just have your attention, and I'll explain this, and then I'll write it up, and I'll just post it online, and you guys can read it. So I know last class I said it is incorrect to say that there's a 95% probability that P is inside your interval. Okay. And so, when you look at this, it kind of sounds like there's a 95% probability, or like 95% of students' intervals will capture the true value of P. But we're not allowed to say there's a 95% probability that P is inside someone's interval. Okay? So the reason why, again, is because the value of P is a fixed thing. There is a 95% chance, but it's only associated with the process, the random process of getting your sample, okay? And so it is correct, and I'll write this and I'll post this, is that it is correct to say there is a 95% probability that a random sample of M&Ms or whatever, that your random sample will produce a sample proportion P hat close enough to the true value of P so that the resulting confidence interval successfully captures P, okay? So there's a 95% probability associated with the random sampling, so that there's a 95% chance that your random sample has a P hat close enough to P that the resulting confidence interval is quote-unquote correct, okay? And I'll write that up, and you can study that. It's a little bit to get your head around, but that's what all of this confidence interval stuff is about. Okay, we'll see you guys on Friday. Good luck as you guys study for the exam.